everyone showing up today, getting into the afternoon of DerbyCon. It's a great turnout. So I'm Paul Coggins. I'm from Huntsville, Alabama. I'm a network security architect to focus on offense and defense on network infrastructure. And so what we're going to talk about is some interesting things that you can do with network infrastructure if you get access to it during a pen test engagement. Or it could be that the bad guys already have access to some network infrastructure and give you some ideas of what they may be doing with it. So kick this thing off, let's talk about how you might initially get access to someone's network infrastructure. One way is you could use SNMP below. Say that you've built up a dictionary of passwords customized for a target organization based on the intel that you've gathered on them. And you take that and combine it with a tool called SNMP below, and what that's going to enable you to do is spoof the IP address of the network management system that is trusted by the network infrastructure, where they have access lists that are locking down the trust relationship of who can touch the network infrastructure with an SNMP packet. Because of the nature of UDP, it's fire and forget, so it lends itself to being spoofed. And in the case the network infrastructure is not doing anti-spoofing, if that has not been implemented at the edge of the network, then you may be able to do a brute force dictionary attack with community strings. And what's going to happen if you use the SNMP below is you're going to specify the IP address that you're going to spoof, specify the target, and then specify if you're able to guess the SNMP community string, it's going to download the router config to your attacking workstation. And once you get that router config, you're going to get all kinds of intel. You're going to know username, passwords, their TACACs, IP addresses. You're going to get a lot of intel on the trust relationships, routing protocols, etc. that will allow you to further escalate your access to the network. And if you've got that information, you could also go, because of the nature of UDP, it's fire and forget, you could go and craft packets and upload a new config to the router so that you could spread influence. So this might be one vector that gets things kicked off for you getting initial access to the router. There's lots of ways to possibly get that initial access, though. So here's one idea. If you get access to the router, something that everybody talks about, the layer 2 ARP poisoning, the different layer 2 protocol attacks, like using Yersinia, various methods inside of a VLAN to be able to do man-in-the-middle attacks, say DHCP, etc. Well, one method you might be able to do if you get access to that router, and I'll give you one of the inspirations behind this talk, is I work on some pretty sophisticated red teams for some interesting people. Let's just leave it at that. And I noticed in a lot of these pen test engagements that we would get access to the routers, and the teams wouldn't know what to do with the routers. They just get a lot of access, get some configs, do the show runs. They might know how to do show tech, but what can you do with it? So that was a lot of the inspiration behind this talk. So here's one of the things that you might be able to do if you get access to that router and you want to gain better access and spread more influence on the network. Is there's a capability called route maps that allows you to do policy routing that will override the routing table. You might have a routing table that is going to direct traffic northbound or certain traffic, say eastbound, but you could go and use a route map and combine it with an access list like a firewall filter and specify the traffic that is of interest to you and configure the route map to override the routing table for the traffic that you've specified as of interest and redirect that traffic however you would like. And using that technique, you could go and create a layer 3 man-in-the-middle attack where you could go and attack traffic, enter VLAN, and say sniff, modify, and inject traffic, enter VLAN once you've got that access to that layer 3 switch or router on the network. It may be that you could go and force and redirect traffic that is of interest to you to a backdoor, say 3G, 4G connection back out to the internet, overriding the routing table so that you can leak traffic out. Or if you're dealing with somebody that's really sophisticated and you're multi-home to the internet and you're running BGP, and whoever's coming after you, they know they have influence out one BGP path, It could be that at the perimeter router, you could override the routing table to force traffic that is of interest to take a specific path out toward a provider that you have access and influence over, so that you could do your exfil the way you would choose to. Just some ideas. Now this is an old school technique that if you're not a router guy, you're in the pen testing, if you're into the red team and all, you need to know about this. This is pretty well documented as an old school trick, and this white paper, the link I have at the bottom goes into great detail on this. I encourage you to reference it. But what's happening here is, in the old days, when we were running AppleTalk, DECnet, XNS, IPX, AppleTalk, all those old protocols that we don't have to deal with anymore, like Banyan Vines and stuff. You young guys, there was protocols before IPv4. One of the things that we would do to get this traffic across an IP network, like say across the internet, is use GRE tunneling so that we could encapsulate in any protocol, including IP, across the GRE tunnel and drop it out at another specified site. What you can do is, similarly, you could take that route mount technique that I mentioned to you, doing the policy routing. You could specify traffic that is of interest to you, build a tunnel between your target router and the router that you own access to, and build a GRE tunnel and force the traffic that is of interest to you to traverse that GRE tunnel so that you could sniff traffic across a wide area network. And that got me thinking. There's a new technique called ER-span. I know a lot of you guys are familiar with doing port mirroring, where you do a span port on your Cisco switch to mirror locally on a switch. And you may know about R-span, where you can mirror from switch to switch, traversing multiple switches. Well, there's a capability called ER-span, where you can go and do port mirroring across a wide area network, where you just specify the destination as an IP address. And that got me thinking, based on what those school techniques of doing GRE tunneling, why can't we go and do this, take what we figured out years ago with GRE tunneling and use that with ER-span to do a mirror? It's another way to exfil traffic off of a network. If you're not looking for it, somebody may be doing it to you. I can promise you the next net router that I get access to, this is going to be used. There will be lots of screenshots of this. Along the same lines of some old school techniques, back when I got into wide area networking, back in like '99, when I really got into wide area router technologies, one of the first ones was DLSW. I built out a large nationwide network for a customer where we would tie in IBM green screen controllers, hang them off of a serial link off of a router so that they could do SDLC protocol back to an AS400. And basically what the DLSW will do is it is designed to bridge SNA, SDLC, and NetBIOS traffic across an IP backbone. It's basically a tunneling protocol. And according to the RFCs, it's designed to do SNA, NetBIOS, SDLC. But you look in the config there, you can see that bridging. You're turning on bridging. Well, here's something about routers that you might not know. If you specify globally that you're going to route a protocol, it's going to route the protocol. But if you turn on bridging and you do not have routing enabled for a protocol, but that protocol is on the network, and you turn on bridging, it'll bridge that protocol. So that got me thinking. What about doing this? Because we're turning on bridging. This is something that's not documented, but if you can get access, if you're playing red team, if you're doing a pen test engagement, you get access to a router and it's running like IP plus feature set that a lot of places are going to have because they're running voice over IP, and they'll have the IP plus capability so that they can do the analog digital integration. What you will also have in that same feature set is the DLSW commands. And then you could possibly go turn on the DLSW tunneling and exfil and influence the network via IPv6. Very few networks are looking for IPv6 traffic, and it's low-hanging fruit. And this might be a method to go and do some tunneling that they're not looking for. And this is not documented anywhere to do this. This is something I figured out how to do. Because nobody uses this stuff. I mean, when's the last time you've seen an SNA network? but it's there. Here's another tunneling technique some of you may be familiar with from the Microsoft world, L2TPv3. Now, I come from a telco background. I spent since like 2000 working in the telco cloud, the original cloud, the WAN cloud. And inside that telco cloud, we do a lot of really interesting things with packets, and it got me thinking about how to apply those in a pen test environment. Well, one of the ways that you could take and bend and twist some networks is you could take L2TPv3, which basically gives you the ability to drag and drop a VLAN across a wide area network. It could be the internet, it could be your private WAN. And you could go and build a logical, what we call a pseudo wire, a logical connection, and where you can tunnel layer 2 traffic and take like your VLAN 10 and drop VLAN 10 out somewhere else in the world. And how we use that in the telco world is you may be like AOL, and AOL doesn't own all the telcos, and they don't own all the access lines, but they will go and lease capability, and what they could do is they could have routers dropped out in strategic parts of the country where they need to provide access, and use this L2TPv3 to tunnel back to their home router infrastructure, and it enables them to terminate a PPP connection. Because you remember, if you look at the bottom of the screen here, PPP is layer 2, and you see that you got PPP encapsulated in Ethernet. It's also being encapsulated in ATM, because ATM runs over DSL, and it goes over to the edge of the network where it gets terminated at that router that's a BRAS. Now, it's really important when you're talking to different customers that you know the marketing terminology. And when you're doing something like terminating DSL or this L2TPv3 connection, you talk to a telco, it's called a BRAS, a broadband remote access server. It's basically a router, but it's all marketing, right? If it was a cable modem, it would be a CMTS, cable modem termination system. So it's going to terminate at the head end, whatever the end destination is, at this BRAS. But in a lot of the router code, the routers that you may break into doing red teaming, the L2TPv3 capability may be there and allowing you to create a pseudo wire connection. And that got me thinking. It's a pseudo wire, and it enables a layer 2. And all of us that do red teaming, one of the first things we learn is about all the fun we can have at layer 2. You know, we all learn, you know, the first day of a hacking class about Cain and Abel and EtherCap, and that's all cool. And you know, you might, if you're in the right class, you learn about Yersinia. If you're in my class, you're going to learn a lot about Yersinia. But what about doing it across a wide area network? Instead of just thinking about doing it in a local VLAN, what about being able to do it across the wide area network? Most likely, they're never going to see it coming. Never going to see it coming. And this is some low-hanging fruit. So if you get a hold of a router, this is something to be thinking about. What about going and enabling a tunnel like this from a target router and thinking about a bad guy? If you're doing forensics, incident handling, if you're responding and you're tracing down some really weird traffic where no matter what you do, traffic is getting popped out at different places of the world, and it doesn't make any sense the way that the routing is working. What if somebody has done an L2TPv3 tunnel just north of you and is dropping traffic out somewhere and influencing the traffic to go the way that they want to? That could be happening. Along the same lines, CALEA, Patriot Act, wiretap stuff is, everybody talks about that. Well, here's what's going on with that. If you're a Cisco guy like me, the terminology is lawful intercept. I encourage you to go and look at a paper by an elite router hacker called FX out of Germany. He's got a really good paper on lawful intercept that I recommend you go look up. And I give you some references from the Cisco site to go look at about this technology. But basically, lawful intercept is what the telcos are required to have in place, the service providers are required to have in place, and if they do not have a lawful intercept capability where you can basically do an IP-based wiretap, when law enforcement comes up and they serve them a warrant requiring them to give them access to do a wiretap, it's like a $10,000 a day fine for them if they do not have this type of infrastructure in place and enabling a legal wiretap. And what happens with the Cisco equipment is the lawful intercept is enabled by SNMP version 3. Now you have to have a special version of code to do the lawful intercept. It's not in every build of code. You have to have a build of code that has the lawful intercept. feature set. But basically what is going to happen is the target of interest is going to be doing its communication. A warrant is going to be served, and they're going to track the target of interest. The communication is going to be based on an access list that defines the traffic that is of interest, and the target is going to be communicating as normal, but a perfect copy will be sent to the monitoring system so that a full PCAP can be pulled of the traffic that is of interest. And it's all implemented above board and legally, and the telcos really scrutinize and control access to that and verify that there's a good warrant in place with the proper paperwork, in my experience, to enable this capability. Now, something to make you aware of, how they make sure that they're targeting the right, if you're the telco, making sure that they're targeting the right customer and that the wrong person doesn't get their door kicked in at 3 in the morning by a SWAT team for whatever the reason that they're being targeted. One of the things that they use is a capability called Option 82 in DHCP. Have any of you guys heard about Option 82? Option 82, basically what happens if you're coming from your DSL modem or your fiber to the home, when your CPE, when your router, your broadband router, your computer comes online and sends a DHCP request, the access gear that you're terminating your connection to, your first initial layer 2 hop, is going to see that DHCP request, and it's going to inject into the header the physical chassis name and the physical interface that your connection is terminated to, and then it sends it up to the DHCP server that supports Option 82 logging, and that will map along with your MAC address to the IP address that you've been allocated, and then they can be correlated to the billing system of what your physical street address is, because in their database they know what physical hardware, what access switch you're terminating to, or DSLAM you're terminating to, and they know the physical interface that you're tied to, that they're terminating your connection so that the right person can get their door kicked in at the wee hours of the morning. Now, what you make you aware of is some people don't like DHCP. You could implement this in your enterprise network. Your enterprise switches support this DHCP snooping. You just need a DHCP server to support Option 82 so that you could get this mapping and quickly correlate where an attack, a traffic of interest may be coming from. You can nail it down. Just something to be aware of. A lot of people in the enterprise SMB environment are not aware of Option 82, so I want to make you aware of that. But that's how we use it in the telco space. But what if we're doing red team? What if we're under a legal authorized contract agreement to go in and do a pen test, and we pop somebody's router? Now, if you're in a telco environment, they probably already have the lawful intercept feature set there. If you're in an enterprise or similar environment, you may need to go and check and see if they have the memory and flash and RAM, and if it's inside your rules of engagement, to go and give them some new code. I can tell you, if you get access to the router, they're not going to know that you gave them new code. If you get into a router guy's network and you're able to log in, they're going to think it's a bug or an anomaly, and they're not going to notice that you uploaded code. And so, if it's inside the rules of engagement, go and give them some new code. Upload the lawful intercept feature set. If you have access to a legal license from Cisco, upload that code for them and give yourself a new feature set, and then go and execute the lawful intercept capability and show them how the exfil could be done. That you could define all the traffic of interest. Point A and point B will communicate from a target standpoint as normal, and you're exfilling traffic the whole time. It'll be a real nice learning lesson for everyone. This is a complicated attack, but it's a good one we need to make our customers aware of, especially if we are able to get access to their network infrastructure. Along the same lines of bending and twisting networks, if you're doing red teaming, you get access to the router, and you know that there is a target-rich environment behind that router. It may be that you can do some router trickery to enable to further influence the engagement. This scenario here is a little bit complicated. Had a service provider. They're pulling IPTV video services from the cloud. You know, everything goes to the cloud today. So they're pulling video services from the cloud, multicasting cable TV, IPTV to their head-end on the right. And the way that multicast traffic works, there's a rule called reverse path forwarding. The system that is receiving the multicast traffic or the routers inside the internal router infrastructure, it will not forward that traffic if it does not have a route back to the source of the multicast traffic. And in this case, this network infrastructure on the right, this data center has, and this is a security feature, it has its routes, the default routes headed back north toward the source of the multicast video. But what you see in the center of the screen in this particular engagement, we hacked the router, and we know that there's all this infrastructure behind that router in this data center, but we can't get a two-way connection. And what we discovered is looking at the router and looking at the layer 2 information, looking at the ARP table, we could see all of this infrastructure back there, but we could not get the two-way connection. And it turns out that they had their default routes pointing back north toward that cloud provider. And so we could not get a two-way TCP connection. But a trick we figured out is you could turn on NAT at that perimeter router, turn on NAT, and do some static mappings and translations, and the router will proxy the connection for you. When you turn on NAT at the edge there and start mapping IP addresses to the IPs you see on the inside, then you can establish that two-way connection. And what happened in this case is they have a bunch of Solaris systems that have not been patched and updated, because when you get these kind of networks built, you kind of leave it alone because they work, and you don't want to be the one to break a service like cable TV, because this is basically what this is doing, cable TV over IP. You don't want to be the one to apply a patch and knock out, you know, the TV service, especially like SEC football. You don't want to be the one to do that. It's a career change opportunity. In the environments that you get into some of this, they're not into this patch management. That's for the Microsoft Enterprise guys. You get this infrastructure in place. You don't leave it alone. Somebody retires, or there's a whole new upgrade, new technologies. So what ended up happening is we were able to go and spread a great deal of influence over the network by just enabling NAT there, enabling the being able to establish a two-way connection. Another thing we see when we plug in, if there's any kind of routing protocol, now this is going to apply to EIGRP RP and RIP, but most of the time we're going to see OSPF in the majority of the networks you're going to see, and the red teams are leaving this on the table. This is some low-hanging fruit, and if you're doing red teaming, you've got to go and get these protocols. The layer 2 protocols and the layer 3, the routing protocols are being left on the table, and I'm coming in after all these compliance audits, and we'll get an engagement and come in, and this is like low-hanging fruit, and it's never been touched. We need to do more diligence and be more diligent about getting these protocols and helping our customers clean these up. So what's going to happen is you're going to see something like OSPF. We'll pick on OSPF for this presentation. And how OSPF works is you have you break up OSPF. If you have a large enough network, you break it up into areas. You have to have area 0. Area 0 is the backbone. But if you have a large network where you need to segment it so that you can aggregate traffic and take the CPU load off the routers, because the network is getting too large, you'll break it up into sub-areas like Area 1, Area 2, but they have to have a router that touches your Area 1, your Area 2, what have you, will have to touch Area 0. And then if you have an external connection, say a BGP connection, that would be like your ASBR router that would go and talk BGP to the internet or possibly talk to another network. And you're going to break those up because it's always going to be running an algorithm called shortest path first algorithm, and you're going to break it up so that you can lower the CPU utilization on those routers. But you're going to see this traffic multicast out on the wire when you plug in with your Wireshark. Now here's what you need to know, is that it's some low-hanging fruit. You can really spread some influence on the network, and 9 times out of 10, when I plug into a network and I see the protocols there, there's going to be no authentication or it's going to be clear authentication, though MD5 is an option. MD5 will not be used. If authentication is there, it's going to be clear text, and you're going to see it out there in your Wireshark or your network miner. And it's going to be low-hanging fruit. This is going to be as good as having an NT 4.0 box. I mean, this is low-hanging fruit. This is some good stuff, and it's out there because the auditor that gets there before you, they didn't know what to do with this. So what I have up there in the upper right-hand corner there for you, where you can go do some more research or some tools that you could go use to exploit this during your red team engagement. Quagga is you could use Quagga. Something that I would highly encourage you to go check out is the Naval Research Lab has a tool called Core. It's a network simulation environment that basically fires up a bunch of Quagga routers. It is awesome, where you can do BGP, OSPF, do some really high-end network simulation. You could fire that up. You could download the VM off of their side. You could integrate that into your target network. And this is how I think about it. Take Quagga, take that network simulation environment in Navy Core, and blow up a really large network, simulate a really large network in this VM environment, and start using the IP address space of, say, Microsoft, Google, NSA, CIA, all those IP addresses that you should not be scanning. Put those into the network simulation environment and introduce those. Tie yourself into the OSPF process that it's out there in the clear or no authentication. Join that routing process, advertise those networks in, and source your attacks from your attack system from those IP blocks. And if they have Splunk, if they're doing any kind of logging, they're going to be running around crazy thinking that, say, the government, Chinese, Russia, is attacking their network, and you're on the inside the whole time and introducing all this into their router logs. It'll be really funny. I mean, can you imagine? I mean, I know you guys, all you red team guys, y'all are thinking about networks. You're going to go do. I can do this too. But I mean, it's there. But Navy Core would really enable you to do that. Very easy. You could use the Dynamips would be just as easy. But if you don't have a copy of Cisco router code, the Navy Core environment, I'll keep going back to, is cool. You could roll your own with something like Scapy if you've got some Python skills. But there's no reason we couldn't inject routes. We could not, if it's inside your rules of engagement, my rules of engagement, denial of service is always off the table, and I'm not into doing DOS. I like to go and do cool things without having to do denial of service. You could, set up yourself a man in the middle, or like I said, go and test their logging to see if they can detect why is China or NSA attacking them? Because you're filling their logs up from injecting those routes into their network. Similarly, there's been a lot of conversations out here lately about BGP. Has anybody not heard about the BGP hijacking that's happening? YouTube got hijacked a while back. Facebook was hijacked. Recently, there was on the web a conversation about how there was a service provider out of Iceland and Belarus that was caught hijacking, probably accidentally, hijacking IP traffic for a section of the world. It happens pretty regularly. There was an incident the other day out of Canada where some Bitcoin, there was a target for like 10 or 12, like a dozen networks were targeted to go after Bitcoin. Well, this is how it basically works. Here's how the BGP works. You have the different organizations have an autonomous system number. In the U.S., you would go to ARIN to get your AS number if you were routing BGP traffic to the internet because you're multi-homed to the internet. And you would also get independent IP space from ARIN. And if you're in Europe, you'd go to RIPE. You might go to AFNIC if you're in Africa, LATNIC if you're in Latin America, APNIC if you're in Asia Pacific, to get your BGP AS number in your IP space, and everybody, all the different telco service providers, and if you're multi-home to the internet, you would have one of these AS numbers. And in some places, this is a key point here. Though you may have a point-to-point connection, or you think you have a purely point-to-point connection, a lot of places there is a layer 2 cross-connect where where the co-location facilities, the different telco service providers are meeting, and they have a layer 2 cross-connect. Basically, think of it as a VLAN connection between the different networks so that they can establish BGP connections. And some of these places are very extremely secure with man traps, guards, gates, and guns. You could eat off the floor. They got floor-to-ceiling caged racks, alarms, very, very, very secure. But others, you got cabling just coming out all over the place. I mean, it's hard to tell where one customer network begins and ends because it's just such a rat nest. And I'm seeing all this on the news about all these BGP attacks, and that got me thinking, how easy would it be? Because you get physical access into some of these places, and I'm thinking of one in the southeast right now. I won't say where, but there's one in the southeast, and there's just a huge rat nest with the cabling just strode out all over the floor, inner rack. It's just a big mess where these cross connects can happen. And all of the old school techniques, the day one of your hacker class, all those old school techniques, and some of them we talked about today, could be easily executed by gaining access into one of those networks where they're doing the co-location and doing the cross connects between the different providers and enabling some of these attacks. Something to be thinking about. And so you could be going and doing with that layer 2 access, that layer 2 access could go and enable some of these advanced exfiltration or just the local VLAN type attacks. But here's what's happening with the BGP. If you haven't been following this, you have the different AS numbers. You might have, say it's AS4 and it's AS6 that are communicating with each other. They're transferring traffic between each other. Well, you might have something in someone in AS5 here. They may go rogue. They may be under the influence of others. Let your mind roam about who's doing the influence. And they could go. There's nothing to stop them, because of the inherent trust relationship in the internet, from going and taking your IP space and advertising your IP space as their own, and then influencing traffic at the global level to swing over to their network so that they can execute a man-in-the-middle attack on a macro layer, at a global layer, and be able to do modification, injection, maybe drop the traffic on the floor. Now, if they drop the traffic, of course you're going to know it. But what about just sniffing the traffic, or what about modifying and injecting the traffic? Point being is, if it's important to you, you better be encrypting it. At the same time, you could be, they could go, personally, what I've seen is mostly they're hijacking the IP space, but it could be that they hijack the autonomous system number as well as the IP space and introduce it from behind a routed network that they have influence over, and not only take your IP space, but also impersonate your AS number. But I got a new talk that I'm presenting now at some other conferences on MPLS. Any of you guys do MPLS VPNs? If you're not doing encryption across those MPLS networks, I have to warn you, whoever is doing the BGP hijacking most likely has access to the routers where MPLS is configured as well. I'll build out these networks, and wherever I build them out, the guys who have access to BGP have access to MPLS, and it's all running on one core, big core router. We call them BFRs, big freaking routers. And we're virtualizing the routers the same way the enterprise guys are virtualizing the servers. And we carve up the routers into logical different networks using VRFs. And you might have a network running for BGP Internet, another one for the cable TV voice, another one for, say, video services, your Metro Ethernet VLANs, etc. And whoever has access to those routers has access to your VPNs. And if those MPLS VPNs, if you don't have control of the encryption on those endpoints, it's not out there in the media yet. Nobody's talking about it openly. Though I've been pulled aside and told personally by someone who has seen this that they discovered in their network that out of their MPLS private VPN cloud that they had, another foreign network was shooting out their internet connection, and they traced it back, the source, into the VPN, the MPLS VPN network. Who knows what was happening and how long that was happening before they discovered that traffic coming from the inside of their logs, their router logs. So I want to encourage you to put some kind of VPN. If you're a Cisco shop, if you're in a Cisco like I am, look at the Cisco Get VPN and put a VPN device behind that perimeter router of all your wide area network connections to make sure that you have a good AES encryption, because you're inheriting a trust relationship with a telco. And you've got to trust that the telco and all their staff and whoever they have peering agreements with and whoever they have a physical cross-connect with, that everybody can be trustworthy. And you don't know where all the meet points are, where all the cross-connects are, especially if you're an organization that has that's international, where they have international peering points, where they don't own the pipes from the U.S. to, say, Asia or somewhere in South America. There's going to be multiple possible peering points, and when you point through there's an opportunity for the trust relationship to get exploited, either at layer 2 or at layer 3 in the routers, where they're peering together, and your network sees one big network connection end to end, but it's multiple networks tied together, and so that MPLS can be exploited just like the BGP is, but you're not going to see it. What you'd have to look for is to be looking. If they're just sniffing traffic, you're not going to see it if they're just sniffing your traffic. But if they're but they could be joining your MPLS VPNs. And if you see that they're joining your MPLS VPNs acting like a remote site, then you're going to have to be monitoring your routers. Don't raise your hands, but how many people would know if somebody joined their routed network and started advertising EIGRP, OSPF, BGP routes into their network? Would you know and detect a new IP prefix being injected into the network? We've got to be looking at that. Everybody's starting to look at their server logs. We better be paying attention to these router logs and the updates to your routing table, because somebody may be influencing that. Wanted to leave time for some questions. Anyone have any questions? Sure. The gentleman in the black back here. For which problem?
Well, it would seem like you would always have to be a layer up above it.
Well, what I encourage is, at a minimum, be getting net flow, the session traffic of who's talking to who, how much, where, when, and when did the conversation start, when the conversation's end. Get that telemetry data. Kiwi syslog has been around for a long time. SolarWinds has them now, but it's very, very simple to implement the Kiwi syslog and pull your router logs and be watching for changes in your router updates. Some of the other vectors I gave you be running Kiwi syslog, SolarWinds, Cisco Works, what have you, to monitor your configurations. If something happens with your configs, if there's a change in your configs, have configuration monitoring and control and know when somebody logs in, when do they log in, and what changes did they make to your routers, and be doing configuration control and know what happened and when did it happen and was it justified. That's a good place to start. And the other thing is on the BGP side is to go look at something like BGPmon or Renesas or Team Cymru. And they proactively will monitor your IP prefixes to tell you whether something's happening to your IP prefixes. I have to ask you, who is watching their IP prefixes to see if somebody's hijacking? If I go and hijack your IP prefixes out of Southeast Asia, would you know it? Would you know it, or you're waiting for somebody to tell you and read about it on the web? You could go to BGPmon and have an alert sent so that you would proactively know if somebody's doing it. If you don't have the budget for it, go out and look at the BGP Looking Glass servers. Go and Google BGP Looking Glass. It's free. You can get access to route servers around the world and baseline what is normal for your IP prefixes. What does normal look like for your networks from different parts of the world? And if you got scripting skills, you could go out and query the Looking Glass servers and roll your own tool to proactively notify you. But if not, for the BGP hijacking, look using one of those services. For the MPLS, you got to use encryption. If you're not using encryption, then you better be watching. You might as well assume that that somebody could be sniffing your traffic in the wide area network. You're inheriting a trust relationship, and somebody could be sniffing that traffic. The infrastructure's there. I put the infrastructure in myself so that we can sniff at 10 gig. I put in systems that can sniff 10 gig right off the core backbone. When we do it, we're doing it for troubleshooting, analysis, to solve anomalies and problems. But if someone was to go rogue in an organization, there's nothing to stop them from sniffing your traffic and exploiting the confidentiality and integrity of your network. So I recommend the encryption and the monitoring of any kind of adjacency changes. Do you have a question? You got white shirt?
That was my question.
Okay.
One of the guys had asked a question about a tool that one of the tools could help, which can help detect some route change and stuff. I am working with the PBS team and we're actually developing some plugins that will detect all of the LSAs, all of the EIGRP updates, and we're doing RIP updates and the BGP updates over the next 6 months. So with PBS piece of stuff coming out in the next 6 months.
Oh, great. That's cool.
For the layer 2 stuff, you could use programs like our block for communication, something on all the switches too, and then any other changes, regular changes, more consistent.
Right.
Working with some metro research environments where customers are using layer 3 switches rather than routers, and in the Cisco space, are any of those export techniques like the L2TP or the DSWL or LW, are those available in any of the switch platforms or that basically router platforms?
It's primarily the routers where I've seen it. But when, sometimes it gets gray between routers and switches depending on the model. When you especially get into the carrier class, large enterprise, the feature sets can bleed over, but I don't recall seeing them too much in the lower level enterprise devices. Right, right. Yeah, you get into the 3700s, you can turn on MPLS and lots of features, especially for the metro feature. Any more questions?
Yeah, how do you think software defined is going to change the landscape?
It's going to be very disruptive. I look at software-defined networks as the network apocalypse. I'm going to embrace it because I have to, because I'm too young to retire. I like routers. I want everybody to leave my routers alone. It's okay to go and virtualize, and disrupt the enterprise server guys' environment, but leave us router guys alone. That's my personal opinion, but it's going to be very disruptive. The new architectures, and it's going to change. It's going to drastically change the attack surface. It's going to push it toward the controller. It's going to have to really lock down the controller. In most cases, if you have 100% SDN network, and it's going to really. I think if it's implemented properly, where you lock down the control plane and management plane, if you have that mind toward that level of security, I think SDN is going to make it easier to narrow that surface of attack. Right. Right.
Now, expanding the attack surface because you've got normal attack surface we're talking about, and now you have a new attack surface.
Yeah, if there's not a culture that is focused on minimizing the exposure of the control plane and management plane, control plane being your protocols and management plane being your network management access, if there's not a strong mind towards securing that, you're just adding more targets to the network. Because when I go in and I'm working on a red team, I'm going after the network management infrastructure. And if I can get to the network management infrastructure, it doesn't matter if you've got a traditional routed network or if you've got SDN. If you get a hold of the HP OpenView, the Cisco Works, the SolarWinds, whatever element management system they got from some XYZ vendor, I mean, all bets are off. We're off to the races. I mean, access is access. If they don't control, they don't limit that control plane, management plane access, surface of attack. Any questions? Any more? Well, I really appreciate everyone showing up, sticking around today and attending my talk. Really appreciate it. And here's my contact info. I'm always online. I try to be real responsive. So if you want the slides, I'll give you the slides and try to answer any questions you might have. Thank you.